NASA's James Webb Space Telescope has just delivered a bombshell discovery that's sending shockwaves through the scientific community and fundamentally altering our understanding of how planets form. In a groundbreaking observation, James Webb has captured direct images of massive exoplanets with atmospheres containing unexpectedly high levels of carbon dioxide, a finding that shatters decades of astronomical theory. This isn't just another space discovery. It's a paradigm shift that forces scientists to completely rethink how giant planets come into existence throughout the universe. And with each new revelation from Webb's unprecedented capabilities, the mysteries of our cosmic neighborhood grow both clearer and more complex. Buckle up. Let's dive into how this discovery is rewriting astronomical textbooks and why it matters for our understanding of the universe. The discovery that challenged everything: James Webb's revolutionary exoplanet images. The astronomical community has been studying exoplanets for decades, but nothing prepared them for what James Webb would reveal. The telescope's groundbreaking observations focused on the HR 8799 system, a distant star system located 133 light-years from Earth. What makes this system extraordinary is its 4 massive exoplanets, all gas giants larger than Jupiter, orbiting their star at distances which are comparable to our own outer solar system. Previous observations had given us glimpses of these worlds, but James Webb's near-infrared camera and mid-infrared instrument provided unprecedented clarity. The images revealed not just the planet's presence, but allowed scientists to analyze their atmospheric composition in remarkable detail. What they found sent shockwaves through the scientific community. The atmospheres of these young giant planets contain significantly higher levels of carbon dioxide than expected, a signature that immediately raised red flags about our understanding of planetary formation. William Ballmer of Johns Hopkins University stated in a press release that by spotting these strong carbon dioxide features, we have shown there is a sizable fraction of heavier elements in these planets' atmospheres. This quickly caught the attention of astronomers worldwide. The implications were immediate and profound. The presence of these heavier elements directly contradicted the established models of how giant planets form, particularly the widely accepted core accretion theory. But this wasn't just a minor discrepancy in the data. It was a fundamental challenge to decades of astronomical consensus. The carbon dioxide conundrum: what these atmospheric signatures really mean. The detection of substantial carbon dioxide in these exoplanets' atmospheres isn't just an interesting chemical finding. It's a crucial clue that forces us to reconsider fundamental aspects of planetary science. Carbon dioxide, along with other heavy elements like oxygen and iron, shouldn't be present in such high quantities, according to the traditional core accretion model of planet formation. In the core accretion model, giant planets form when a solid core gradually accumulates gas from the surrounding protoplanetary disk. This model predicts that the atmospheres of these planets should be predominantly hydrogen and helium, similar to Jupiter and Saturn in our solar system. The heavy elements should be concentrated in the core, not distributed throughout the atmosphere. But James Webb's observations turned this expectation on its head. The carbon dioxide signatures detected by James Webb suggest that these planets have atmospheres enriched with heavy elements, which challenges the core accretion narrative. This enrichment indicates that these planets may have formed through a completely different mechanism, possibly through direct gravitational collapse of gas and dust in the protoplanetary disk. This alternative formation pathway would allow for a more even distribution of heavy elements throughout the planet's structure. What makes this finding particularly significant is that it doesn't just affect our understanding of the HR 8799 system. It forces scientists to question whether the core accretion model, which has been the cornerstone of planetary formation theory for decades, is as universal as once thought. The implications extend to how we understand the formation of all giant planets, including those in our own solar system. Before we delve deeper, if you find my videos insightful, I would appreciate a like and a subscribe. This really helps me reach more space enthusiasts just like you. Now, let's launch into our next point: rewriting the textbooks. The scientific impact of James Webb's carbon dioxide discovery. The scientific community is still processing the full implications of this discovery, but one thing is clear: our understanding of planetary formation is undergoing a radical transformation. The traditional core accretion model, which has been the dominant theory for decades, now faces a serious challenge from the gravitational instability model and other alternative theories. Dr. Jennifer Wiseman, senior scientist of the Hubble Space Telescope, emphasized the broader impact of this finding. She said, "Science progresses when observations challenge our existing theories. This discovery is exactly the kind of evidence that pushes the field forward, forcing us to refine our models and develop more comprehensive explanations for how planets form." The implications extend beyond just exoplanets. This discovery may also prompt scientists to re-examine the formation of our own solar system. If the core accretion model isn't as universal as once thought, could Jupiter and Saturn have formed through different mechanisms than previously believed? Could the composition of their atmospheres hold similar surprises? James Webb's game-changing technology, how it's redefining exoplanet science. The James Webb Space Telescope represents one of humanity's greatest technological achievements, and this discovery highlights exactly why. Previous telescopes like Hubble provided valuable data about exoplanets, but Webb's capabilities are in an entirely different league. Its advanced infrared instruments allow it to peer through cosmic dust and detect the faint light from distant exoplanets with unprecedented clarity. Webb's near-infrared spectrograph, NIR-SPEC, and mid-infrared instrument, MIRI, are particularly crucial for this discovery. These instruments can break down the light from exoplanet atmospheres into its component wavelengths, creating a spectral fingerprint that reveals the presence of specific molecules like carbon dioxide. This level of detail was simply impossible with previous technology. James Webb's ability to directly image these exoplanets is equally impressive. Direct imaging of exoplanets is extremely challenging because the light from the host star typically overwhelms the faint light reflected by the planets. James Webb's coronagraph technology, which blocks the light from the central star, allows astronomers to see these planets directly. This capability has opened up a new era in exoplanet research, allowing scientists to study worlds that were previously invisible to our instruments. The cosmic perspective, rethinking our place in the universe. James Webb's groundbreaking discovery of carbon dioxide-rich exoplanets has fundamentally altered our understanding of planetary formation and opened new avenues for exploring the diversity of worlds beyond our solar system. The implications of this discovery extend far beyond the HR 8799 system. As James Webb continues to unveil the atmospheric compositions of more distant worlds, we may find that planetary formation is far more varied and complex than our current model suggests. This could have profound implications for our search for habitable planets and our understanding of how common Earth-like worlds might be in the galaxy. The big questions now are, how will astronomers revise their theories to account for these unexpected findings? Will we discover that multiple formation pathways are common throughout the universe? And what other surprises does James Webb have in store as it continues to peer into the atmospheres of distant worlds? What's your take on this astronomical breakthrough? Do you think these findings suggest we need to completely rethink how planets form, or are they just an interesting exception to the rule? Drop your thoughts in the comments below, and don't forget to subscribe to the Space Grid for the latest updates on space discoveries. Thanks for watching, and see you next time.